Hello and welcome to the Solid Print 3D printing segment today. So today I am going to start with an introduction, just give you a little introduction to Solid Print and myself, and then I'm going to go over some production 3D printers, and then some 3D printers that we'd recommend only using for prototyping, and then a couple of honourable mentions at the end, which might be really interesting for some of you to know about for some very niche applications out there. So I'm George Field. I'm an industrial 3D printing consultant at Solid Print 3D. So my background is in SolidWorks. I had 5 years experience in SolidWorks, working as a design engineer. And I started out 3D printing at home, and then I kind of naturally fell into 3D printing with Solid Print 3D. So production 3D printers, what makes a production 3D printer? It's the hardware itself, so the 3D printer, but then also the materials and the software. So you need all of those three things working in unison to ensure that you get reliable 3D prints very quickly, and also with the sort of mechanical properties that are advertised, and no sort of inconsistencies in the print happening frequently. So a good few examples of production 3D printers. One would be Markforged. So the 3D printers there use composite materials to build very strong parts, and they use an online bit of software called Eiger. So everything is fully enclosed, closed source, ensuring that you get very reliable results consistently. Formlabs, another one which I'll go over shortly, that uses a different type of technology called SLS 3D printing, which can be very, very useful for producing high, larger batches of parts without support structure or anything like that. And then BigRep finally, which are very good for building larger parts or nesting lots of smaller parts together to do production runs. So firstly, Markforged.
Could you break a 3D printed part? Not this one. This part was reinforced with continuous carbon fiber on a Markforged printer. It's 23 times stronger than plastic, with a significantly higher strength-to-weight ratio than aluminum. What does that mean for you? It means that for the first time ever, you can print high-resolution, affordable, complex parts that don't break. You go from idea to end-use part in less than a day. However you choose to change the world, we're here to help you do even more. Reinforce your part with continuous strands of carbon fiber, fiberglass, or Kevlar. Our cloud-based print management software optimizes your print for you, making the transition from CAD to part easier than ever before. Are you ready to bring your manufacturing operation into the next industrial revolution? Request a sample part from Markforged today.
Markforged uses a patented technology called fiber reinforcement. So that allows them to build parts that are stronger than aluminium, but 40% lighter. So basically they'll use a plastic material that kind of acts as the concrete, called onyx, if you like. And then they will inlay a fiber reinforcement inside that plastic, which is like a rebar running through concrete, which dramatically increases the strength, but isn't visible on the end part. So you still end up with really nice surface finishes on the parts, very good accuracy, but inside that plastic, you'll actually have a rebar, if you like, running through it, which is that continuous fiber strand, which can be the carbon fiber, Kevlar, fiberglass. So you might be wondering, when do I fiber reinforce my parts? You might want to do it when you need something to be very, very strong, like if you're replacing an aluminium component, for example. You'll probably want to fiber reinforce it, increase the durability of a part beyond conventional plastics, and also just optimize it for performance. So just to put into perspective, how strong are the Markforged 3D printed parts? When they're carbon fiber reinforced, you can see on this stress strain graph here, the strength far exceeds that of a bit of aluminium. So there are plenty of tricky applications that you can take on with this kind of technology. So we've got a customer out there that's bending 3mm sheet steel with a 3D printed press tool made on a Markforged machine, just to give you some idea of the sort of applications that you can take on. Lots out there though, which I'll cover in just a second. So another feature of the Markforged machines is something called Blacksmith. So the industrial Markforged machines have an onboard laser inspection scanner, which not only allows you to produce inspection reports right off the machine, but it also creates a closed feedback loop. So when it's 3D printing the part, it's looking at the design, the 3D design file, and then comparing that to what it's actually printing, and then making adjustments over time to make the printer more and more accurate. So unlike, something like a CNC machine, they will naturally deteriorate and become less accurate over their life cycle, whereas the industrial Markforged machines will become more accurate over their life cycle. So just to give you one quick application, I'm not going to go over lots of different applications, so I don't have time today, but just to give you one, this is a 3D printing lifting tool. That's the first CE-rated lifting tool, lifting an engine piston from a shipping vessel, which weighs about a ton, which was previously done with this steel tool that you can see up the top right, that's in yellow. So we've now switched to a Markforged 3D printed lifting tool, carbon fibre reinforced, and that's allowed this customer to save a significant amount, not only in weight, which was 75%, but also in cost as well, around $100,000. So pretty significant savings with this case study in particular, but then also just shows what sort of advanced applications you can take on with Markforged 3D printing. So just to give a summary of the different applications that you should be thinking of applying this technology to, one would be high strength and lightweight end use parts. So just to give one example of that would be something like a motorbike brake lever would be perfect. It's made out of aluminium at the moment. You want it to be lighter, stronger, and then you're going to bring the cost down massively. In-house things that you can tackle with this would be jigs, fixtures, and tooling. So that press tool that I mentioned earlier would be one of the more advanced applications, but assembly jigs, inspection fixtures, all manner of things along those lines. If you have anything like that, feel free to reach out to us and we'll start a conversation. End effectors and assembly line items, assembly guides, engineering materials that you might need as well in the automotive and aerospace industry. If you need fire retardant and ESD safe components, those kind of advanced materials are ones which we can print in on the Markforged 3D printers. And any highly accurate and precise applications where you're thinking of applying 3D printing, Markforged would be the kind of recommended brand that we'd recommend for those kind of more advanced parts where you need them to be meeting tolerance. And finally, functional prototypes.
One of the big challenges we had with the bending cell was to basically design and integrate everything in a really timely fashion. We were able to actually do it in about 6 months, and that would not have been possible without the additive. We found Markforged by researching for the best printers out there for commercial and industrial quality printing.
One of the parts we make at Lean Machine is an aluminum wire clip like this. The tooling in general, what we used to use was big heavy steel tooling like this to put in our press brake. So one thing we found we could do with printing was actually print these tools instead. The big thing that we saw with Markforged was it took a big step from a hobby printer to something that you can actually make parts out of. And we saw a few sample parts and then we kind of jumped in with it and haven't looked back. So the first step is that you load the blanks into the trays, which hold 200 parts each. After that, the robot picks the parts out of that tray using an array system and then takes it into the press brake to bend them one at a time. Because of the 3D printing, you have complete control over the profile of your bend. The onyx is actually very good for friction and it doesn't leave any marring on the part at all. So we have a much nicer part with the printed tooling and it's easier and cheaper to make the tool. So it's kind of a win-win.
With the continuous fiber, we make a printed part that not only could compete with aluminum parts, but in many cases actually be a better part. So one of the biggest real gains that we found with the 3D printer is that if we want to get parts made, we don't have to go and schedule them out in the machine shop. We don't have to order tools. We don't have to make drawings. We can skip all of that and we can just get the parts made on the printer. We come in the next day, the parts are ready, we can start testing with them. and we don't have to go and check that they're right. And being able to have every single feature on a printed part coming out within 2 or 3 thou with Z accuracies of less than a thou. I mean, the accuracy stuff is huge. It's like, okay, these guys can pretty much do anything.
So that brings me on to our next production 3D printer, which is produced by Formlabs, which is pretty new to the market, came out earlier this year. And that's the FuseOne and FuseSift.
Design and manufacturing workflows are closer together than ever, but our ideas still often exceed what we can physically realize. A new wave of independent manufacturing starts now with the FuseOne, an affordable, compact SLS 3D printer with an intuitive workflow. Selective laser sintering, or SLS 3D printing, is relied on for printing strong, functional nylon parts. In the past, SLS has been too expensive and difficult to use for many businesses. The FuseOne allows you to fabricate production-ready parts and high-performance prototypes. Control your entire process from iterating on your first concept design to manufacturing finished products. The process starts in Preform, our print preparation software. Preform's part packing algorithms can automatically arrange many models in a build. During setup and printing, the Touch UI walks you through every step. Monitor your print from the touchscreen or from your computer via the integrated live camera. Once your print is complete, transfer the build chamber to the FuseSift. This safe, efficient powder recovery station completes the workflow. FuseSift will automatically dispense and mix used and new powder after you set the ratio. Reduce waste by recycling powder at a 30% material refresh rate. This means you can print with up to 70% recycled powder. After you've transferred a completed build to FuseSift, swap out the entire build chamber from the FuseOne for non-stop printing. SLS 3D printing fuses nylon powder layer by layer. The unused powder supports the parts during printing, so you can create complex, interconnecting designs with no need for support structures. Nylon parts balance strength, flexibility, and detail, so prints are ready for rigorous functional testing or to ship ready-to-use products to customers. It's time to rethink product development and take control of your own manufacturing. The FuseOne, production SLS, finally within reach.
So FuseOne and FuseSift use a technology called SLS 3D printing. So unlike Markforged, where it's basically taking a filament and then melting it out of a nozzle and then building up the parts layer by layer, this technology SLS will use a laser and a bed of powder. And basically when the powder gets hit by this laser, it gets sintered together to build your part out of the powder. So what sort of benefits are there of using SLS in production? We're using proven end-use materials. So nylon 12 would be the main material that we print in most of the time, but we also have nylon 11 available to us and another couple on the horizon. But you can look at a nylon 12 datasheet off the Formlabs FuseOne, and you can see that it's biocompatible, fire retardant, and you can apply that sort of material to existing applications. You don't have to get those materials recertified for your application. Nylon 12 is a pretty well certified material already. So the benefits, the further benefits of SLS is opening design freedom. So because the parts are all self-supported in this powder, we don't ever have to build things like support structure. The detail is defined by a laser dot, so we can do very fine amounts of detail. So this 3D printer in particular, I would say, any sort of geometry that you have there, you can throw at this 3D printer and it's going to be able to deal with it. So we can make very complex, intricate structures, and we're not having to go back to the drawing board after a 3D print wondering why this didn't work, or why is it taking so long to clean up this, that, and the other. It will just print what you give it. It's a very, very flexible technology. So the other benefit of SLS is it's very high throughput. So because we're nesting parts in this powder, we can nest parts one above the other. We can totally fill that 3D volume with parts. And the cost of the materials as well is not all that much either. So if you're looking at doing small production runs of parts where nylon 12 material would be suitable, this is a very, very competitive solution, with the Formlabs FuseOne SLS technology now being at around £14,000 for the printer, and then £6,000 for the sift. And then with everything you need to get started, it usually comes to about £30,000. Whereas SLS technology before the FuseOne was released, any industrial SLS machines were around 100k plus. So the price point has massively been brought down for this technology, and it's very, very competitive with injection molding even on small production runs. And then you also get the added benefits. You can change your design whenever you like. You don't have any sort of design constraints. And we're happy to talk with anybody that would be looking to use this as a production avenue. So as I mentioned, the applications of the FuseOne: end use production, small batch production, and production of very novel and intricate designs. Because nylon 12 is biocompatible, it's also very, very useful in the medical industry. So lots of medical prototypes, and also the fact that we can print any sort of geometry. So even like anatomical models, anything along those lines, it's very, very well suited for those applications as well, and fully biocompatible and sterilizable parts. And just to give you some idea of what nylon 12 is like as a material, we're going to compare this to an ABS used by Stratasys, which is very widely used in the 3D printing industry for in aerospace and for jigs and fixtures, things like that. And you can see that nylon 12 is a very, very useful material with high tensile strength, high elongation at break, and then the heat deflection temperature as well is also relatively high. So there's a lot of applications you can take on with just nylon 12. Some more advanced applications you might need to be looking at nylon 11.
At BigRep, we solve the world's most difficult manufacturing challenges with advanced, large format 3D printers. With a global reaching reseller network and offices located in Berlin, Boston, and Singapore, we help innovators from all over the world make their vision a reality. By engineering brand new extrusion technologies and massive cubic meter 3D printers, we've molded additive technology to make real products for real people. Starting with the BigRep 1, we upscaled additive technology like never before, creating the largest serial production 3D printer the world had ever seen. Now, with the BigRep Pro and Studio G2, we've raised the bar even higher, introducing our engineering-grade materials to additive for real industrial solutions. By creating futuristic additive applications like the Loki Podcar and Nira e-bike in our innovation consultancy Now Lab, we push 3D printing forward in both technology and vision, while providing the tools that innovators need to bring the future to today. Providing every layer you need for the perfect industrial solution, BigRep is redefining additive.
So the other production 3D printer would be BigRep. So BigRep produce very large FDM machines. So they basically take a filament and then heat that and then extrude it out of a nozzle, similar to Markforged, but they don't have the patented continuous fiber reinforcement technology. They're just extruding a plastic. So these 3D printers are around a meter cubed build volume. The BigRep 1 suitable for prototyping applications. The Pro and the Studio G2 better suited for advanced end use parts and production applications. So why would you need a large 3D printer? If you have large parts that you need to be printing, it's pretty straightforward, one-to-one scale parts, then this is a very good option rather than joining small parts together and going down that avenue, which can take a lot longer. And also BigRep are a very reputable brand based in Berlin in Germany, and they have many industry partners with which they've developed materials with, and the engineering grade materials that they have available to them are very, very good. There's carbon fibre reinforced materials that they have in their portfolio now, which are great for taking on advanced applications in aerospace and automotive. We have a customer using a BigRep machine for producing some jigs that are being used to hold helicopter blades together on shipping vessels for the MOD. So, a very industrial solution. And just to give a couple of applications of where you can use BigRep 3D printing is Enduse Manufacturing. You can nest lots of parts in the build area that would be very tricky to machine geometries, and then just leave it running over a weekend, with 3D print all of that production run. Large jigs and fixtures as well on assembly lines. So Ford using them for their assembly jigs. Then also patterns as well is a very good application. So sand casting patterns, investment casting patterns, both of those good applications to use a BigRep for, especially if you're needing to do large patterns. Also things like you wouldn't think of, like 3D printed casts for the construction industry. You can take these out onto site relatively easily, cast concrete into them, rather than having a big kind of like MDF structure making up your mold that you'll be casting into. Just use the 3D printed one. So just to summarize, why would you use production 3D printing over conventional production options? Your inventory, you can turn your inventory from a physical one into a digital one, so reduce overheads massively rather than having parts sitting on the shelves. You just have your digital inventory and you 3D print those parts as you need them. Production costs as well, especially if you're doing small production runs or just a few parts, you don't know what your demand's going to be. It can work out far, far cheaper to 3D print your parts rather than outsource the manufacture of those, especially in the case of things like aluminium parts. They can become really costly, and if you can 3D print those on a Markforged machine, we see like really big return on investments there. And manufacturing as well, you can bring that in-house, have more control over your supply chain, rather than having hold-ups along the way at different stages. And logistics as well, that there's also environmental impacts to take into consideration here. If you're 3D printing your parts in-house, there's far less moving about of things, and the process as a whole is much better for the environment. A new product development as well, you can develop your new product on the machine that you would actually be looking to do the production on. So if I was developing a product for on the FuseOne, for example, I can start doing the prototyping on there, part fill the build chamber, so not do a full 3D print filling the whole volume, just do a couple of parts, and then when I'm happy with that, I can then scale that up on the same machine, really reducing the amount of like unknown elements in that process, because I've been using my production option at the prototyping stage. And then also, made to order, as I covered earlier, you don't have to have minimum order quantities. You just print off as many as you need from your digital inventory. So I'm going to cover some 3D printers that we'd recommend for prototyping only. So I've covered the more advanced 3D printers for production applications, which you can also use for prototyping, and they are very good for prototyping. But these machines, if you're just looking to get started and kind of dip your toes in, these machines would be the best ones to start with just for prototyping, and then you can look at moving into production after that if you'd like. Ultimaker, a very, very good brand, very reliable 3D printers, very versatile with a huge range of materials available to them. There are many machines out there like this. There are many FDM 3D printers that are open source, whereas Ultimaker is in one of the most reputable brands and is highly regarded as the easiest to use, the most reliable due to the material profiles that they have set up. And also the software that they use is considered industry-leading software for open source FDM printing. I mean, there's a industrial 3D printing company using their bit of software on their £50,000 plus printers, which they've just reskinned. So the software is top-notch. Formlabs. So Formlabs also do SLA 3D printers as well as the SLS one, which I covered earlier. So the difference being that these printers print parts from a bath of resin, and the sort of parts you get off of these machines have the best surface finish available. So these kind of 3D printers are really, really well suited for places like design consultancies, where you want to be maybe prototyping any sort of small product that you might put on Dragon's Den or anything like that, because the finish that you get off of the machine, the parts look like they've been injection molded. It's very difficult to determine whether it was printed on a Formlabs SLA machine or if it's just been injection molded. You can barely make out any layer lines. The materials on these as well is very, very diverse. So you can print in anything from like a rubber sort of elastic material to something that replicates a nylon to something that's very rigid with fiberglass particulate in it called like a rigid 10K resin, they call it. And there's also two of these machines available, the smaller Form 3 and the Form 3L for printing larger parts. And finally, the BigRep one, which I covered very briefly earlier, very good for producing large-scale prototype items. So for production, we would probably recommend the BigRep Pro or the Studio G2 due to the enclosed volume and heated chamber, which basically allows it to produce more dimensionally accurate parts. The BigRep one, however, though, will do a very good job of mocking up large parts, but if you need to be working to find tolerances and in advanced engineering grade materials with carbon fibre particulate, then perhaps the BigRep one won't cover those things, but for large scale mock-ups, it's great. So what else might we be able to help with? So some new technologies I'm going to go over now, which many of you may not have applications for, but it's interesting to know about, I think. So we have a new machine that will 3D print electronics in 3 dimensions called the Nano Dimension Dragonfly. So this machine you can basically print a circuit board, so you have components on the circuit board nested one above the other on the board. You can integrate things like RF antennas that would usually be a separate PCB item into the same circuit board. So that there are many things that you can do to kind of improve your PCB designs, and most importantly, reduce the overall size of them, because you can do things like side mount components onto PCB boards. With this sort of technology, you're working in 3 dimensions rather than previously you'd be working in 2 dimensions. So very, very interesting technology, and that leads me on to our next technology, which is new to the market, which is the Massit M1000. So this machine will produce autoclavable composite mold tools. So if you know anything about the composite mold tooling industry, it's very, very expensive to get composite mold tools produced. It takes months and months to get them delivered, whereas this technology is looking to streamline that process. So we'll be able to produce epoxy composite mold tools right off the machine, and then you can start doing your carbon fiber layup onto those printed mold tools, massively reducing the costs and lead times associated with that. Some other 3D printing technologies claim to be able to do this, but what you will find is, because they're printing in layers, when they put their mold tools into an autoclave, the thermal expansion is not uniform, so they'll expand more in the Z-axis rather than the XY, because they're printed in layers. Whereas this technology uses a new technology called cast in motion. So it's actually casting the epoxy resin into a void that it creates by printing 2 walls of material to produce your composite mold tool. When that part is finished, is isotropic in strength. So when you put it in an autoclave, it will expand uniformly in a way that you can predict, which is very important for advanced applications like in aerospace, where you need to retain a high degree of accuracy and meet tolerances. So thanks very much for listening to the 3D printing segment. I did cover quite a lot in a very short amount of space, so sorry if if there was anything that I did whiz over and you wanted to learn a little bit more about, but this will be uploaded onto the Solid Solutions website, and we'll also be putting it onto the Solid Print 3D website. Anything that I have mentioned, you can find out more through our website. So if you're curious to know a little bit more about the production 3D printers that I mentioned, the prototyping printers that I mentioned, or any of the the honorable mentions at the end where we have cutting edge technologies like the 3D the Nano Dimension Dragonfly or the Massit M1000, just go to solidprint3d.co.uk and you can learn a little bit more on any of these technologies that I've mentioned today. Thanks very much for listening. Cheers.